Hey guys, so today we're going to talk about one of my favorite topics. I love this. It's geometry and algebra put together, but it's still one of my favorite topics. We're going to talk about the Pythagorean theorem today. Pythagoras was a Greek mathematician, and this is probably one of the most famous theorems in all of math. Like you can ask anybody, and they will say, they may not. They'll remember the name. They might even remember the actual formula that goes with it. But what we have to know is when are we supposed to use it? And the hint is looking at these shapes right here. These shapes are very specific. Um, they are triangles, but they're even more specific. They are right triangles. So this little thing, this little corner right here that I'm drawing in these little corners, these tell us that these are right triangles because these are right angles. So these are 90-degree angles, right? 90-degree or right angles. So these are right angles. By the way, that's the little symbol for angles. So these are what we would call right triangles. All right. So this will only work for right triangles. So you're always going to be looking for this little symbol. It may not be down in the top bottom. They could be on the top, but you're going to look for 90-degree angles or nice looking corners is what a lot of students first think of them as. All right. And then each one of these parts has a name. So we would say that the part here, this bottom one, well, not even the bottom one, the two sides like this that make up this right angle, these are called legs. So this is a leg and this is a leg. That's what they call them. They're legs. And we're going to label this one little a and we're going to label this one little b. It doesn't matter which one you label A and which one you label B. That's not as important as the third side. And this third side right here, this third side right here, that one right there, is super important. This one is always going to be opposite that right angle. So if I look at this right angle here and I go this way, that third side this is the important one. This one's called the hypotenuse. Okay, and we always label this one with the little letter C. So we use the beginning of the alphabet, A, B, and C, to label these. The legs, A and B, they can be interchanged, but C is the really important one, and it's always opposite this right angle. All right, so what I want you guys to do right now is kind of pause the video. I want you guys to draw one similar to this, and then I want you to label it. Which sides would be the legs, and which side would be the hypotenuse. Go ahead and pause. Okay, so here's what we should say. So if we remember that the legs make up the right angles. So these two are the legs. So that's my leg A. And we're going to say that this one is leg little b. And then that right angle symbol is always going to point to the side that's the most important to label correctly, the hypotenuse. Oops, hypotenuse. And that's what we're going to label with side C. All right. Now, here's the reason why that's really important. The Pythagorean theorem says if I know the lengths of two of these sides, so if I know one side's 2 inches and the other side's 3 inches, I can figure out what the length of the third side is using this formula or this theorem. So here's what this theorem says. It's to find the missing length, of a side, well, I should put a side, of a side of a right triangle. So remember, these only work for right triangles. Okay? So only right triangles, no other shapes. And here's the formula that we use. We say a and we raise it to the second power. So remember, we call that squared. A squared plus b squared equals c squared. So we take one of the legs the length of it, we square it. We add the length of the second leg, and we square it, and it's going to equal to the hypotenuse squared. So it's an equation, and if we know two of these, and it can be any combination of the two of these, we can solve that equation to find the third side, the length of the third side. So that's what we're going to be working on today and for the next lesson. So here are our directions for today. First, we want to write an equation. We can use to find the length of the missing side of each right triangle. Then we want to find the missing length. Because we're using squareds here to solve things, remember when we talked about in our last lesson, to solve things, we're going to have to use square roots. So we may have to round answers to the nearest tenth if we got to do square roots of things that don't come out nice. So this is why calculator is going to be nice. All right, so here are the steps that we're going to use for this. Step number one, we want to label each side. So label each side. So that means you're going to have to redraw it or screenshot it and use your annotating tools on your iPad. But we're going to label each side, the A, B, and C. Remember what we said. The important side to remember is the one opposite the right angle. Here's my right angle, and opposite that is always, if we look up here, opposite that is always the hypotenuse. So that's C. So this is going to be side C. And then remember what I said about A and B. Those two, they can be changed up. It can be either one of them. So I'm just going to say that this side is A and this side is B. Okay. And so that's number one. So we're just going to label our sides, which one is which. Let's go with orange. So the second thing we're going to do is then substitute values into a squared plus b squared equals c squared. So substitute just means put the numbers in where the letters or the variables are. So always start by writing a squared plus b squared equals c squared, because that's what we're starting with. And since we are going to be solving an equation, I'm going to kind of put those lines in there like we have been doing. And so we want to substitute in. So I know what A is. According to this picture, A is 7. So I'm going to say A is 7. Now, it's not just 7. It's 7, according to the formula, it's 7 squared. So I've got to remember that exponent. Plus, and according to the picture, B, what we labeled, that's 8. So this is 8, but it's also raised to the second power. And that's going to be equal to, okay, according to the picture, this is our missing side. We don't know it, so we're going to keep this as C squared, okay? What we have now is a multi-step equation. So it's going to be a little bit more than we did in the last lesson, but still not as difficult as our last, or as involved as our last problems, our last unit. So what we're going to do is we're going to solve the equation now for the missing side. So what we're going to have to do first is I actually have to square these. So remember, this is not 7 times 2. This is not 14. 7 squared off to the side. Remember, 7 squared is 7. Remember, we're making a square, 7 times 7. So that's 49. Plus, and then this is 8 squared is 8 times 8. So that's 64. And that's equal to, we still don't know C, so that's going to stay C squared. All right. So now our simplifying is going to involve exponents. We didn't have to do that before, but we're going to have to do that now. And now all we have to do is add up 49 and 64, because according to this, that's what we have to do. Oops. So 49 and 64 is 113 is equal to C squared. And now this problem looks like the ones we did in our last lesson. So to undo the squared, we need to square root both sides. So I'm going to square root both sides. Remember, that cancels out. So we get C is about equal to, so remember, now we're going to have to take the square root of 113. So I'm going to go into, where did it go? I'm going to go into my calculator, And clear those out. We're going to do the square root of 113, which is 10.63. Okay, so this is about equal to, now remember what we had before. We always had positive, negative, 10 point, now it was 10.63, so we want to round to the nearest tenth. So here's my tenths place, and when I look over, that's a 3. So the 6 is going to stay the same because the 3 is too small. So this is going to be 10.6. Now, inches, because we are actually measuring something. Now, I'm not going to box that in yet, because something that we have to think about is, do I really have two answers here? Let's think about that. When I'm measuring things, do I measure? Now we got to think about what makes sense. Do you measure in positives and negatives, or only positives, or only negatives? If you think about a ruler, there is no negative side, right? So it's not going to include the negative answer. So when we're solving something where it involves a length like this, we only need the positive answer. So we're going to say that the missing length of side C is the positive answer, because negatives don't make sense when we're talking about lengths. Think about a ruler. Rulers are all positive. Okay? So that's how you use the Pythagorean theorem. All right? So let's try another problem, because this one's going to be a little bit different. On this one, so we squared them and we had to add them up on the same side, right? This one's going to be a little bit different. So first things first, we're going to label our sides. So I know that the side that goes opposite, like that, that's C. So this time I know what C is. And I don't know the bottom one, which I call A, and I do know that B is 5. All right, so let's start by writing down A squared plus B squared equals C squared. And let's substitute values in. So I know A squared is just going to stay A squared, because I don't know what that is. B is 5, so plus 5 squared equals, this time I do know C squared, or C. C is 10, so this is going to be 10 squared. Let's simplify what we can, so let's square what we can. I don't know A squared, so that's going to stay A squared. I do know that 5 squared, so remember 5 squared is 5 times 5, which is 25. So this is going to be A squared plus 25 equals, remember 10 squared is 10 times 10, which is 100. Now here's where it's different than the one we just did up above. Up above, the numbers were on the same side. On here, the 25 and the 100 are not. So to get A squared by itself, or to get A by itself, we've got to do some undoing things and moving stuff around. So the opposite of a positive 25 is we're going to have to minus 25 from both sides. So this is our equation solving. Coming back, we're going to minus 25 from both sides. So now we've got A squared equals 100 minus 25 is 75. And we can square root both sides, and we get A is about equal to, let's see, square root of 75, 8.66. So it's about equal to 8 point, now remember 8.66. I'm looking at the tenths place and the number next to it. The 6 is bigger, so this is going to get plus 1. So it's going to be about equal to 8.7. Don't forget your units, meters. So that was me rounding it up. All right. So that's kind of the two different ways. You may have them if A and B are you know them, then A and B are on the same side, and you would add them up. Or if you know C and one of the other legs, then you're going to have to subtract to get your answer. All right, so let's try one more. We're going to go through this one step by step. I want you guys to pause through it as you go. So the first thing I want you to do is label your sides. Go ahead and label your sides, and then when you're ready, come on back. Okay, so to label our sides, remember the first one I would go to is the one opposite my right angle. and that's my C. So this time I know what C is. And then we'll go to A and B. So A is here, and B is the side we don't know. All right, the next thing I want you to do is to write down the formula with the A's, B's, and C's in it. All right, the formula that you should have wrote down was A squared plus B squared equals C squared. Okay, so now I want you to substitute the values in, pause the video, substitute the values in, and start working on solving it. Okay, so let's see when you put in the numbers. So we've got, do we know A? We know A this time. So A is 13 squared plus B is the side we don't know. So we'll say B squared equals C. We know that side. It's 20 squared. 13 squared. Remember, 13 squared is 13 times 13. That's 169. So this is 169 plus, we don't know B squared, so we're going to leave it like that. And then we have 20 squared. So 20 squared is, remember, 20 squared is 20 times 20. That's 400. So this is going to become 400. All right. So on this one, notice that I've got numbers on opposite sides. So we want to get this, start getting this B by itself. So I am going to subtract 169 from both sides. And we get B squared equals 231. And then we're going to square root both sides to get rid of that squared. And B is about equal to, let's see, the square root of 231, 15.19. So if we want to 15.19, if we want to round to the nearest tenth, we look at the 1, and the next number to it is a 9. So we're going to add a tenth there. So this is going to be about 15.2 feet. Remember, we are only using the positive answers because we're talking about lengths. Think about rulers. If I was going to use a ruler, it would just all be positive numbers. All right, so this is the Pythagorean theorem. There's a couple more things we can talk about that. We will in another lesson, but this is kind of the basics of it. So remember, you're going to label your sides, write the formula down, or that's the formula that's in the theorem, substitute values, and solve. Round your answers to the nearest tenth because calculators are our friend today. This is how you show your work, my friends. All right, have a great day, and I'll talk to you later.